This is Professor Pelton. This is part 1 of chapter 5, section 5, determining the zeros of a polynomial function, thus the x-intercepts essentially on the graph. So if I set a function equal to 0, okay, right, and f of c equals 0, then x minus c is a factor. If x minus c is a factor, then for that c value, you plug it into the function, you get 0 essentially, or i.e. the x-intercept. Okay, all right, so that's what we went over in the prior section. Now we're going to do it for higher powered functions. All right, so I'm going to do the same problem here twice, once with synthetic division and once with regular long division. So I'm saying x plus 2 is a factor of this trinomial, or cubic rather, not a trinomial. So I'm going to do long division, so x plus 2 is going to divide into x to the third power minus 6x squared minus x plus 30. Okay, let's make a better x than that. Okay, so x squared times x is x to the third. X squared times 2 is plus 2x squared. So if I subtract, I'm going to get negative 8x squared. Bring down the minus x. So I'm going to need to multiply by negative 8x. So negative 8x times x gives me negative 8x squared. Negative 8 times 2 is going to give me negative 16x. So if I subtract that, I'm going to get 15x. So next I'm going to multiply by 15. 15 times x is 15. 15 times 2 is 30. So since there's no remainder, that means it went in perfectly, which means x plus 2 is a factor because it divided into the trinomial. Okay, I can do the same thing with what's called synthetic division, which is what I'm going to use throughout this lesson because it's a lot quicker. So I'm going to take the numbers negative 1, negative 6, negative 1, and 30 and place them in a box like this, which are the coefficients of the original function. And on the outside, I'm going to put negative 2, which is the 0. And the question is, where do I get that negative 2? Well, if you take the factor x plus 2, right? If you actually solved it, you'd get negative 2, wouldn't you? Okay, because x plus 2 is the factor, and 2 is the 0, or negative 2 is the 0, rather. And it's just a matter of adding and multiplying, right? Just doing good old grade school math, right? So I'm going to add and get 1. I'm going to multiply by negative 2. I get negative 2. I'm going to add and get negative 8. I'm going to multiply by negative 2 and get 16. I'm going to add and get 15. I'm going to multiply it by negative 2 and get negative 30. So all I'm doing is adding followed by multiplying it by whatever numbers in that box. And what you notice is nothing's left over. And I got the same answer, right? This is the same answer as this, okay? This means 1x squared minus 8x plus 15. Okay, so if I write the function down, f of x equals 1x to the third minus 6x squared minus x plus 30. If I rewrite the function now with the factor divided out, I divided out the factor of x plus 2, and I'm left with 1x squared minus 8x plus 15. So if I multiply those two back, I get the original cubic. So I can keep going with the factoring. So f of x equals x plus 2. And this factors, right? So I get 1x times 1x all over 1, but I'm not going to put that. Let me make a better 2 than that. This is actually working out because this is a third powered polynomial. So there should be 3 answers, right? 3 zeros, 3 factors. Okay, so 1 times 15 is 15, which is 1 times 15, 3 times 5, negative 1 times negative 15, negative 3 times negative 5, because 2 negatives also make a positive. Well, we want negative 8, so clearly negative 3 and negative 5 are the correct ones, right? So if I set it equals 0 using the factor theorem, x plus 2, x minus 3, and, whoops, x minus 5, those are our factors. Okay, normally I don't list out factors explicitly, but I'm going to do that here for the sake of lesson. So my factors, right, are x plus 2, x minus 3, x minus 5. Okay, so my zeros, Okay, so if I actually solve these, x plus 2 is 0, so x is negative 2. X minus 3 is 0, so x equals 3. And then x minus 5 is 0, so x equals 5. Okay, so I found all the zeros in the factors, and those are in fact, the zeros are in fact the x-intercepts on the graph, and there's 3 of them. All right, pause the video, do the student problem, do it with both long division and synthetic division, and compare. Okay, so if I do this one with long division, I get 2x minus 3 divided into 2x to the third minus 9x squared plus 1x plus 12. Okay, let's see. So times it by x squared times 2x is 2x to the third. X squared times negative 3 is negative 3x squared. So if I subtract, I get negative 6x squared plus 1x when I drop that down. Okay, so I need to multiply it by negative 3x now. Negative 3 times 2x gives me negative 6x squared. Negative 3 times negative 3 is positive 9x. So if I subtract, I get negative 8x, right? I'm going to bring down the 12. So now if I multiply by negative 4 times 2 is negative 8x. And negative 4 times negative 3 is positive 12. So we just proved that it is actually a factor. 2x minus 3 divides in, it is a factor. Let's do it synthetically and see if we get the same thing. All right, so I get a 2, a negative 9, a 1, and a 12, right? So what I want out here is a 3 over 2. Well, why the heck is that? Well, if I solve 2x minus 3, okay, I get 2x is equal to 3, or x is equal to 3 halves. That's my 0, right? Okay. All right, so if I make a straighter line than that, I kind of want a little raw there. There we go. So I'm going to add, and I'm going to multiply. 3 halves times 2 is 3. I'm going to add, I get negative 6. I'm going to multiply. 3 times 6 is 18, divided by 2 is 9. I'm going to add, and multiply. 3 halves times 8, so that's 24, divided by 2 is 12. So that went in perfectly, okay? But wait a minute. This is 2x squared minus 6x minus 8. That's not the same thing, right? That is not the same thing. So did we make a mistake? What went wrong? Well, nothing went wrong, actually, because if you think about it, what we really have here is 2x minus 3, okay? That is equivalent to x minus 3 halves, right? So I like the one on the left personally. It's a little bit easier to write, and then the right-hand side one, but you can write either one essentially. So in the long division, we used 2x minus 3. In the synthetic division, we used 3 halves, which is equivalent, right? And it's just a difference of a factor of 2, because you notice the 2, the 6, and the 8 could just be factored out. So if you look at the calculator, if you actually multiply them out, okay, this and this give you the same answer when you multiply them, which is back to the original function. But this has a common factor of 2 still in it. We didn't factor out when you do it this way. That's the only difference. Okay, so either one you do, it's still going to work out. So I'm going to use the synthetic in this case, just because I have it written there. So the original function is 2x to the third minus 9x squared plus 1x plus 12. Okay, so f of x equals, I'm going to factor out a x minus 3 halves. Okay, and that's going to be left with 2x squared minus 6x minus 8. Okay, so f of x equals x minus 3 halves. I'm going to factor out a 2. So I'm left with x squared minus 3x minus 4. Perfect. Okay, now we just need to factor that, right? So f of x equals 2, x minus 3 halves Come on. All right, so 1x, 1x. Okay, so we have 1 times -4 is -4, which is 1 times 4, 2 times 2. But one of these has to be negative. Well, we're trying to get -3, so it has to be this one, which is a +1 and a -4. Okay, so the factors are 2, x minus 3/2, x plus 1, and x minus 4. There we go. Those are the factors. Let me make a better 4 than that. Here we go. Oh, I'm going to multiply that by 2 to get the equivalent. Sorry, I forgot the 2. All right. Okay, where was I left off? All right, so my zeros. So is my factors, right? Okay, so zeros. X equals. Okay. So x minus 3/2 equals 0, so x equals 3/2. We already know that. Okay. X plus 1 is 0, so x equals -1. And x minus 4 is 0, so x equals 4. Okay, there's our zeros. Okay. So in all of these cases, I gave you a factor. So I told you 2x minus 3 was a factor, and then I told you that x plus 2 is a factor. Well, the next page, we're going to use the rational root theorem, because what if I don't give you any factors? You have to figure them out all for yourself. So if this is a 4th power polynomial, a quartic, there's 4 of them, but you don't want to check infinite number of numbers. That's taking too much time. So you need some kind of method to narrow down to a simpler, smaller list. So that's what we're using here, P over Q. P is the factors of the constant, and Q is the factors of the leading coefficient. So as long as it's in descending order in polynomial form, that'll give you the list of possible rational answers. If the answers are imaginary or irrational, you won't get them, but we're just working with the rational ones. Okay, so let's make our list first of possible answers, and then we know there should be 4 since it's a 4th power polynomial. All right, so P over Q. So P is 6 and Q is 2. You don't need to include the negatives. We're just doing factors. There's no negatives in factors. So the factors of 6 are 1, 2, 3, and 6. The factors of 2 are just 1 and 2. Okay. So we include 1 because it's not just prime factors. Okay. So the possibility list of all the zeros is P over Q, plus or minus. So 1 over 1, 1 over 2, 2 over 1, 2 over 2, 3 over 1, 3 over 2, 6 over 1, 6 over 2. Okay, so that's my list of possible values. And I can do positives or negatives in either one of these cases. The smaller numbers are more likely to be the answers. The higher ones are less likely probability-wise. So 6 is the least likely answer. 1/2 is one of the more likely answers. And they won't all work. It has to be able to divide in perfectly or divide out. So if I try 1/2, for example, we'll try 1/2. So I'm going to do 2, -7, 4, 7, and -6. Okay, so why is this one not going to work? So I'm going to add, then I'll multiply by 1/2. I'm going to add, I'm going to multiply by 1/2. I'm going to add, I'm going to multiply by 1/2. Okay, oh, that's a positive 1/2. I don't know what I'm doing there. 1/2 times 1 is 1/2. Okay, so if I add, 7/2 is really 14, so that's 15/2. So if I multiply by 1/2, that's 15/4, which is not going to go in perfectly. So this is not an answer, right? So we don't care about those. Don't give those to me when you're solving. All right, so if I start at the beginning of my list with 1s, we'll start with 1. Whoa, that is not a 1. Not even close. Let's try that again. So if I start with 1, so 2, -7, 4, 7, and negative 6. Okay, so I'm going to add, multiply by 1. 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 Oh, that one worked out perfectly. Let's rewrite the function. So, I'm sorry, it's not a function, it's an equation in this case. It's already set to equal 0. Okay, so 0 equals x minus 1. Okay, well, that comes from this right here, because if I solve x minus 1, I'll get 1, won't I? And then 2x minus 5x minus 1x plus 6. Okay, so what is the power of those? Well, the original problem was fourth power. I just took 1x out, so now I'm left with third, 2, and 1. Okay, all right, so the next one on the list will be negative 1, right? So let's go to negative 1. So if I take out a negative 1, I'm going to do 2, negative 5, negative 1, 6. Now, notice that I'm taking over where I left off. Okay, I'm not going back to the original problem, which is the fourth power. Now I'm trying to break down this cubic, which is 2x cubed. All right, so I'm going to add. I'm going to multiply by negative 1. I'm going to add, multiply by negative 1. I'm going to add, multiply by negative 1. Oh, that one actually worked. Perfect. Okay, so rewrite the problem. 0 equals x minus 1. And then now I have an x plus 1, because if I solve x plus 1, I'll get that 0, right? And I'm left with 2x minus 7x plus 6. So what power is that one? Well, this one is a third power that I just divided out of, so now I'm left with a second power. Okay. So it looks like we're going to have to factor this. All right. So we'll go right here. So 0 equals x minus 1, x plus 1, 2x over 2. All right, so 1 times 6 is 12. So 1 times 12, 2 times 6, negative 1. Oh, no, 3 and 4, sorry. 3 and 4. Okay, so then we have negative 1 times negative 12, negative 2 times negative 6, and negative 3 times negative 4. All right, those are all the factors of 12. Well, we want negative 7, so that's clearly the combination there, right? So negative 3, negative 4. All right, so we have a common factor of 2 we can take out there. So 0 equals x minus 1, x plus 1, 2x. What is this? 2x minus 3. I can take out a 2 from the second one and be left with x minus 2 all over 2, which cancels. So 0 equals x minus 1, x plus 1, 2x minus 3, and x minus 2. So those are my factors, right? Okay, so my zeros, okay, comes from solving for those. So x minus 1 equals 0, so x equals 1. We already knew that one. X plus 1 is equal to 0. X is equal to negative 1 when you solve. We already knew that one. And then these two we just came up with. 2x minus 3 is 0. 2x equals 3. So x equals 3 halves. And then x minus 2 is 0. X is 2. Okay. All right, pause the video. Try the student problem for yourself. Okay, so let's make a list of the possible answers. So P is the constant, which in this case is 9, and Q is the leading coefficient, which in this case is a 2. Okay, and again, you don't need the negatives and factors. So the factors of 9 are 1, 3, and 9. The factors of 2 are 1 and 2. So the possible answers are P over Q, plus or minus. Okay, so 1 over 1, 1 over 2, 3 over 1, 3 over 2, 9 over 1, 9 over 2. Okay, so that is our possibilities. All right, so you can go through the list left to right and only give me the ones that actually work. So if we try 1, it won't work. If you try -1, it will work. So I do -1, and I get 2, 3, -17, -27, and -9, right? Okay. All right, so I'm going to add, multiply by -1. I'm going to add, I'm going to multiply by -1. I'm going to add, then I'm going to multiply by -1. Then I'm going to add and multiply by -1, and that worked out perfectly. So my new equation, 0 equals x plus 1, right? That'll give me -1, right? Then I have 2x minus 1x minus 18x minus 9. So I know that is going to be the third power. Well, how do I know that? Well, the original was a 4, and I took one out. 2, 1, 0. Okay, so the next one is a half and a -1/2. The half will not work, but the -1/2 will. So 2, 1, -18, -9. Notice I didn't go back to the original problem. I'm going from where I left off because I'm just factoring out the cubic now, not the original quartic. So I'm going to add, multiply by -1/2. I'm going to add, multiply by -1/2. I'm going to add, and if I multiply by -1/2, I get 9. So that works out perfectly. So 0 equals x plus 1, and then x plus 1/2. If I solve that, I would get -1/2, right? Then I'm left with 2x plus 0x minus 18. And the question is, what is that? Well, this was the third power, so now I'm left with a second power. Okay, well, here's the thing, though. 2 times -18. If I do the factor tree, that's -36, correct? So that's 1 times 36, 2 times 18, 3 times 12, 4 times 9, or 6 times 6. Okay. Well, here's the problem. I need to get 0. So one of these has to be negative. Is that going to work out for us? Oh, we got to factor out a 2 first, don't we? Sorry. I forgot that. We got to factor out the 2 first. I just noticed the common 2. Okay, so if I factor out the 2, I'm left with x plus 1. Oh, 2. I just did it again. Factor out the 2. So I'm left with x plus 1, x plus 1/2. So I'm left with x squared plus 0x minus 9. Okay, so I think we're good. We're going to factor the other way anyways, but the 2 will actually work out. All right, so you can actually factor this and get 0 because factors of 9, right? So 0 equals 2, and I'm left with what? X plus 1. Come on, come on. X plus 1, there we go. And then I'm left with x plus 1/2. And then x minus 3 and x plus 3. There we go, right? Because you need to get a 0 term in the middle, and that does it. And you split 9, 3, and 3. Okay, so those are my factors. All right, so my zeros. So x plus 1 is equal to 0. X is equal to -1. You can do the 2 also, right? 0 equals 2. Well, that's obviously invalid. X plus 1/2 is equal to 0. So x is equal to -1/2. X minus 3 is equal to 0, and x plus 3 is equal to 0. So x is 3, x is -3. And there we go. Okay, that is the end of part 1.